Data types. Understanding the data type in C is very much fundamental for progressing further. Data types are basically telling to the compiler in specific size of the memory what kind of data can be stored. Either it can be the integer, boolean, character, double, etc. So if you see binary storage of the data types, the integers are represented in the form of 32-bit storage. Storage mechanism varies based on the compiler as well as the processor architecture. In 32-bit storage for the integer, if you see numeric 1 is represented as only 1 in the last bit, whereas 25 is represented as 11001. Similarly, 30 is represented 11110. All the integers are represented as a 4-byte integers. So booleans are stored as a 1 byte. Here, true value is stored as a last one and false is stored as a 0. If you compare both integer and boolean, the last representation for the numeric 1 and true are same, and the value represented by 1 is also the same. Doubles are stored with the 64-bit. So 64-bit binary for 25.4 number is represented as follows. So 8 bits are available as follows, representing the 64-bit. So in takeaway point, you can realize that memory size for particular data type is fixed. Like a integer is considering 4 byte, boolean is considering 1 byte, and double is considering the 8 bytes. In C89, core data types are divided into the 5 basic data types like a character, integer, floating point, double floating point, and valueless. So these all are the keywords like char, int, float, float, double, and void. These are the keywords considered under the C. So based on the system and the processor and compilers, the size of the data type will vary. For example, 16-bit systems like a DOS and Windows 3.1, integer is considered as a 16 bits. Now, in 32-bit systems such as Windows 98, 95, NT and 2000, integer is considered with 32 bits. Based on this knowledge, you can write the program versatile across the different systems. The size and the range of the data type will vary based on the processor and compiler types as well as the operating systems. So never assume the fixed size for any particular data type. Floating point precision. Depending upon the data type, floating point precision will vary. However, the standard C, the minimum range for the precision points are 10 to the power minus 37 to the 10 to the power plus 37. Addition in the C99 has provided for the Boolean data type, complex numbers and imaginary numbers. Here, note that the characters are considered as a 1 byte in usual for the ASCII characters. But if character is outside ASCII character, then depending upon compiler, the size of the character may vary. Void has a versatility and it declares with the no return value. However, we will see the void topic in the generic pointer and flexible for programming in the later upcoming videos. This example demonstrates the 5 core data types available in the C89. First one is a character. It will print the character C in the command line. Second one is an integer which will print the number 50. Third one is a floating point number which will print a decimal points. The fourth one is a double which will give the similar output like the float, and the last one is a void is represented with the print long function having void return type. Print long function will basically give the idea about the impact of different operating system considering the size of a different variables. The print long is printing the long integer value in the command line. Let's run the example and see the output in Windows operating system. In the command line, you can see the first character having the 1 byte, second integer is considering the 4 bytes, floating point 50 number is considering the 4 bytes, and double is considering the 8 bytes. If we go to the long, then long number is defined as a 5, is considered with the 4 byte. Now let's run this same example in the Linux system and see the output. As you can see, in the Linux operating system, the only difference in the output we can see is in the size of the long integer. Here, what we learned today is understanding of the roles and limitation of the each data type, recognize how the system architecture influences the data type sizes. Using this knowledge, we can write the portable code in the C without relying on the assumption about the type size, and we gain the strong foundation to explore the further in the C99.